Hi everyone, this is Arfin, and today we are going to do price forecasting by using Monte Carlo Simulation and by following the approach of Brownian motion. So let's start. So we are going to import libraries, NumPy, import pandas as PD, import pandas underscore data reader, web, import matplotlib dot matplot as plt from scipy dot stats import nom percentage matplotlib and line. Run this. Let's download the data. Web dot data reader. So we are going to forecast apple price. Data source Yahoo. Start is equal to. So here I'm going to work on last 10-year data. So it's gonna be 2010 and is equal to. Then we are going to calculate by using adjusted closing price. Let's run this. The data. Let's check the tail. Perfect. Now we are basically going to calculate the forecasted price. For that, what are the information required in order to calculate price? So first, the formula for price calculation is rate price is equal to yesterday price into e raised to power r, whereas r is equal to drift plus volatility into r, into z, and drift is equal to mean minus 0.5 into variance. So in order to calculate price, we need to calculate R, and for R, we need to calculate drift, volatility, Z factor, which is basically the confidence interval or the significance level actually. And then these information we are going to calculate in order to forecast the price. Let's do it. So first we are going to calculate log return, and log return will be equal to np dot log 1 plus data dot percentage change. In my previous video, I have calculated log return through different ways. So there are so many ways to calculate log return. Either ways are fine, whatever is easy or suitable for you. So you can do that. And there will be no impact or difference in the price return. So let's run this. Okay, let's check the head. Perfect. Okay, so we are going to calculate mean, and mean will be equal to log return dot mean. Take the mean. Perfect. And then we need to calculate variance as well. So variance of log return will be variance. Let's check the variance. Perfect. All right. So now we have variance and mean. We can calculate drift. But before calculating drift, I'm also going to plot this data just to show the pattern. So fixed size is equal to 12, 8. Run this. Okay, so we want to get rid of this Excel support data or something, whatever it is. So for that, I'm going to put semicolon and then run it again. So it's disappeared from here. Now, similarly, we have logarithm. So I'm going to calculate or plot basically a logarithm as well. Fixed size is equal to 10, comma 8. I'm going to decrease the size and then semicolon just to get rid of this. This is the daily logarithm we have. Now, drift is equal to mean minus 0.5 into variance. The drift should be very small number. So, yeah. Okay, perfect. So now we are going to generate a random number. And for that, we are going to generate np.random.ran. And we are going to make 10 by 2 matrix. Check. So it's 10 row and 2 columns. Okay. So this is the random probability we have, and we are going to calculate the distance from the mean point. And for that, norm.ppf within bracket np.random.rand 10, 2. Run this. Price, first we need to calculate R, and R will be equal to drift plus volatility into Z. But okay, I forgot one step here. So I'm going to do one thing. I'm going to intervals. So what I'm going to do here is, since it's a Monte Carlo simulation, so I'm going to generate this data of 1000 in time interval, and I'm going to have 10 iterations. So in that case, we will not put Z. What we will put this formula as it is. And instead of Z, we will replace it with this factor. And inside rand, we're gonna say time interval. To run this first. Time interval, and instead of 2, we're gonna put iterations, which is n. Perfect. So let's run this. Let's check R. Okay. Now, in order to calculate the forecasted price, so we need to have a same matrix where we will pick one number and multiply it with the price. So for price, formula is S E is equal to S naught into daily return of T, and ST plus 1 will be equal to ST into the same or daily return, which is this one R. So, and so on. Now, so what we are going to do is we need to take the last price, which is S naught, and the last price will be basically the first price for the Monte Carlo simulation, or for price forecasting. Okay, so what we are going to do, from where we will get S naught, so it will be basically S naught is equal to data dot ilog. So basically what we are going to do here is we are going to give the location code in the data set, what we have here, which we have downloaded from Yahoo, and we want basically this price. So this is the last data point we have in the data series, and we are going to use this price, and it will become our S naught. So, and this is the last observation. So what we are going to say, -1. So it's gonna be the last price we have. So let's check. 132,069. 132,069. Perfect. Now, so it's gonna be the first price of the 10 columns which we have here. Okay, so for that, what we are going to do is price list is equal to create one more array with the same dimension. So 1000 by 10. And in NumPy, there's a command which gonna replicate the set dimension. So for that, we have np dot use underscore like, and we are going to pass this r. Check. Great. So we have the same data array which we have here. All right. So now, as I have explained, that the first row will be the first starting price which we have here. So for that, what I'm going to do is I'm going to say price list first row will be equal to S0. Check again. Perfect. So we can see that the first row is populated with our last price, and in this case, the first price. Great. So now here I'm going to run a loop, and for that, for I in range 1, 2, the intervals, which is 1000. Price list of E be equal to price list E minus 1 multiplied by R I. So it should not be T, it should be I, because there is no T. I was just remembering this and putting it here. So it's gonna be this. Let's run this. Oops, yeah. So it's gonna be same I. Great. So let's run this. Great. So we have, there's some problem here. Seems like price list of I minus 1, and then R, which is, all right. So it should be E raised to power R. All right, so yeah, so it's gonna be np dot exp. Great. So we got this result. Now let's run this again. Everything will remain same. There will be no impact. The impact will be here actually. All right, so we got the prices. Okay, so let's plot this and let's see how it look like. Okay, so we let me show you something. First, I'm going to make some mistake here. Perfect. Since it's numpy array, so we cannot, it's numpy array, so we cannot plot it directly. So for that, what we are going to do is, I'm leaving it as it is. So for example, if you guys make the same mistake, so you can remember this. So I'm going to leave it as it is. Okay. So for that, what I'm going to do is plt dot figure text size is equal to 8, 12. plt dot. Okay, so I have to get 15, let's say, and it's gonna be 8. Great. So this is the Monte Carlo simulation chart we have here. Okay, so let's calculate the minimum price is $95, and let's check the maximum price as well, which is 830. All right, so that's all for today. Hope you like the video, and if you like it, please like and subscribe my channel. And I would also appreciate if you can share this with your colleague, with your friend, with your classmates. So that would be great, because I'm pretty sure if you are getting, or if you are learning from this video, so I'm pretty sure that they will also get benefited from this, and that's my main purpose for making such video. Thank you so much.